Okay, we use different ways of solving quadratics, but they're not always the most useful as far as using your graphing calculator can be tedious. Not everything factors. Not everything you can solve by the square root. Completing the square can take a lot if you don't have a equal to 1. So today we're going to use what works every time, and it's the quadratic formula, which hopefully you remember a little bit from Algebra 1. So it is opposite b, plus or minus, so add and subtract the square root of b squared minus 4ac and take it all over 2 times a. So what you first want to do is you want to get x on one side, or ax squared plus bx plus c on one side, to determine what your a is, your b is, and your c. Then I'm going to plug it in to the formula. So it's going to be opposite 1, or an opposite negative 1, which is 1, plus or minus the square root of negative 1 squared. I always put this in negative in parentheses just to make sure that this is going to be a positive, minus 4 times a times c all over 2. So this is going to be 1 plus or minus I should have 2a, so that's going to be 6. So it's 1 plus or minus the square root of 1 minus, this would be 1, this would be a minus, this would be 4 times 3 times negative 4, so that's negative 16 times 3 is negative 48 all over 6. So now this 1 minus 48 is 49. So it's 1 plus or minus the square root of 49 over 6. Square root of 49 breaks up into 7, so it's 1 plus 7 and divided by 6 and 1 minus 7. I got ahead of myself. 1 minus 7 and divided by 6. So this is going to be 8/6, which is 4/3. This is an exact answer. And this is going to be negative 6/6, which is negative 1. So 2 answers. Because this parabola is going to cross the x-axis twice at negative 1 and 4/3. Totally not drawn to scale there. Second one, you want to get one side equal to 0. So I'm just going to add 2x squared here. So a is 2, b is 4, c is 3. So it's opposite 4 plus or minus the square root of 4 squared minus 4 times 2 times 3 all over 2 times 2. Negative 4 plus or minus the square root of 16 minus 24 all over 4. Okay, so now I got a new situation that we didn't do in algebra because we didn't do imaginary numbers. We just did real numbers, but now our solution's going to be complex. So it's going to be negative 4 plus or minus the square root of negative 8 over 4. Now we know how to take care of the square root of negative 8. So remember, the square root of negative 8 is going to have it's an imaginary number. So we can write this as the square root of negative 1 times 2 times 2 times 2. So that's square root of negative 1 is I, so it's going to be negative 4 plus or minus 2, because there's a couple of 2's, I root 2. So I'm going to write 2 root 2 first, and we always write the I afterwards, all over 4. Now the last step that you want to do is you want to look at how can I reduce. I can divide and simplify each of these by dividing each term by 2, but I don't want to touch the square root right here. So I'm going to divide negative 4 by 4 and get negative 1. And I can divide 2 by 4 and get 1/2. Or you can write square root of 2i as on the outside over 2. So this negative 1's off to the side by itself. So here is my solution. So when we did algebra 1, we just stopped and said, hey, we have a square root underneath, a negative underneath the square root. So this isn't a real solution. But now we know that there can be imaginary solutions in our complex number system. So let's do this one. 4x squared minus 8x plus 3 equals 0. So it's going to be 8 plus or minus the square root of negative 8 squared, which is 64, minus 4 times 3 all over 8. So it's 8 plus or minus the square root of 64 minus 36 all over 8. So 8 plus or minus the square root of 64 minus 36, 28 all over 8. So the square root of 28, you can break it down, but it breaks down into 2 root 7. So I have 8 plus or minus 2 root 7 all over 8. Now again, I can reduce this, so it's going to be 1 plus or minus 2/8 reduces to 1/4. So now I have root 7 over 4. Now these are exact answers. So they're exact answers because they're written with roots. So round each to nearest hundredth would be, okay, this one's not going to round to the nearest hundredth. This one we're going to keep it because it has an imaginary number. But this one you're going to break out and do 2 different answers. You're going to do 1 plus the square root of 7 divided by 4. Then you're going to do 1 minus the square root of 7 and divide it by 4 to get actual decimal answers. And then round the nearest 2 decimal places. So now we have a word problem here because quadratics, they come in the form of projectiles. Suppose a scoop releases a field hockey ball with an upward velocity of 34 feet per second, where you have this function here, models the height and feet of the ball in time t seconds. When will the ball reach a height of 20? So our height is 20, so we're going to plug 20 in for h. So it's going to be 20 equals negative 16t squared plus 34t. So I'm going to do subtract 20 and do the quadratic formula. So it's going to be negative 34 plus or minus the square root of 34 squared minus 4 times negative 16 times negative 20 all over negative 32. So I calculated 34 squared was 1156. Then I calculated 4 times negative 6 times negative 20, and I got positive 1280. So if I subtract these, I'm going to get a negative underneath the square root. I'm going to have the square root of a negative number, which means it's an imaginary number, which means that there's no real answer to it. So if you had a parabola, what it would look like is if this was h, if the y-axis represents your height, and this is your time, and we're trying to figure out when this height's 20 seconds. The graph is going to look like this. It's not, I shouldn't have it go below here, but it's not crossing 20. The ball never gets higher than 20 feet. It doesn't hit 20 feet. So the answer is D, never. So in that case, when you can know what the discriminant is to tell you how many solutions there are. So that last problem I just did, that word problem, I knew that the discriminant, which is underneath the square root, was negative. So that's how I knew that the parabola never crossed the x-axis. So if you just do b squared minus 4ac, you can figure out whether the parabola has 2 solutions. So if the discriminant is positive, it's going to have 2 numbers because of the whole plus or minus situation. You're going to add and you're going to subtract whatever the square root of b squared minus 4ac is. So it has 2 x-intercept. If it's 0, it's going to have 1 real solution. Because if you think of the quadratic formula, you're going to have plus or minus the square root of 0. Well, that's just going to cancel out. You don't have to add 0 and subtract 0. It's going to be the same thing. And then the last one is you can have imaginary solutions if the number is negative underneath the square root. It never crosses the x-axis. So to determine the number and type of solutions, what you need to do is do b squared minus 4ac. So this one's going to be 6 squared minus 4 times 1 times 9. So that's going to be 36 minus 36. And I get 0. So if I go back to my chart, if I get the discriminant as 0, it's going to be one solution. I don't want to put just one. It reads type and number of solution. So it's one real solution. Now I'm going to do b squared minus 4ac right here. So I do 6 squared minus 4 times 1 times 10. 36 minus 40 is negative 4. So it's not negative 4 solutions. It's a negative number, so there's no real solution, but there's 2 imaginary solutions and no real. I'd really like you to write both of these, 2 imaginary and no real. Don't just write no real. We're stepping it up now that we know that no real solutions means 2 imaginary ones.